Hi guys, afternoon. I hope you're all keeping well. Today we're going to go through the answers to the worksheet that I set you on Monday to solubility and solutions. So if we have a look at the first question, it's asking us the notice is painted on the wall. After heavy rain, the colour ran down the wall. Why do you think the colour ran down the wall after it rained? Because the ink was water soluble. So that means it dissolved in the water. B, what made this type of paint a bad choice? Give a reason for your answer. And it was a bad choice because the water dissolved it. A better choice for this might have been oil paint, because oil paint is not dissolved by water. The photograph shows a tablet dissolving in a glass of water to form a solution. If the tablet is called the solute, what name is given to the water? The water is called the solvent, V-E-N-T. A student placed 4 of these tablets in the glass of water, but not all the tablets dissolved. Give a reason for this. Because the solution was now concentrated. It was saturated even. And what does saturated means? It means that there's so much solute, so there's so many tablets dissolved in our water, which is our solvent, that no more can actually be dissolved in. So it was saturated. So the next question tells me Robinson's fruit squash is concentrated. What does that mean? So concentrated means there is more solute than solvent. So remember, our solvent is the liquid and our solute is the thing we're dissolving into the liquid. And part F is asking, how would you make a dilute solution of Robinson's from the bottle above? You would add water. You would add more solvent. And our solvent in this instance is water. Okay, so in question 2, it's all about a student doing an investigation to find out if the mass of salt added to water affects how long it takes to dissolve it. So she decided to add different amounts of masses. Now remember, mass is measured in grams, so she would have weighed this out and gotten the amount of grams of water that she weighed out. She would have added it to the water and she would have taken the time she would have recorded the time taken to see how much it was dissolved. Now, what's really important here is if we read this line, we can see she says she used exactly 200 at 60 degrees Celsius and the water was stirred each time she added the salt. She used a stopwatch to record the time. So there are things we might need as we go through, and we can see she recorded her results in a lovely table. Part A, give a reason for using exactly equal volumes of water in each beaker. Well, this helps to make it a fair test. If she was using uneven volumes of water in each beaker, it would not be a fair test and we wouldn't be able to compare all of our results. Part B, what difference would be seen if the water in one of the beakers was at 50 degrees while the other was at 60? So 50 degrees is lower. So if we had a lower temperature, we would see that it would not dissolve as much salt. It would also make it an unfair test. Part C. How did the student get the average time? She used a stopwatch to record the time. And the student used averages. Why? By using averages, they are more accurate. And they give a better result. So to calculate the averages, she would have added up the time taken and divided it by the amount of figures she added up. Okay, so the next thing we have to do is we have to draw a graph. So we have to put the mass of salt on the x-axis. So this guy is the x-axis down here. And that means that we also have to put our average time on the y-axis. And there's our y-axis. So now that we have our axes in, we need to plot our points. So our mass of salt, we used the results from the previous page, but our mass of salt, guys, starts at 6 and it goes all the way up to 36. So what we have to be very careful of is that we do it at even intervals the whole way across. So I've decided to go up in 2s and to let each line equal 2. So 2, 4, 6, 8, 10, 12, the whole way up. On the y-axis, we have to put the average time, and this is in seconds. Our lowest is 30 and our biggest number is 95. So I'm going to go up each line representing 10. Now, if I run out of space, guys, I might just only label every second line just to give me a bit more room. And now we're going to start plotting our points. So the first one is 6:30. So where 6 and 30 meet, we're going to put a dot. Our next one is 12 and 53. So there's 12, and we need to get up to 53. So here's 50. 53 is going to be quite close to that. So wherever both of those meet, we're going to have our next dot. Our next one is 19, which is around here, all the way up to 61. Okay, so there's 60. Or that's 70. This is 60. So 61 might be around there. Our next point that we have to plot is 24:30. So we find 24, or 24:75 even, sorry. Here's 24. We bring it all the way up to 70, and we need to bring it to 75. So 75 will be halfway. Our next figure is 30, which is here, and we bring that all the way up to 87. So 30, climb it the whole way up. There's 80, and 87 is going to be quite close to 90. And our last point finally is 36:94. So we bring 36, there's 36. We bring it all the way up to 90, and 94 is going to be roughly there. So now what we have to do is we have to try and do our best to draw a line joining up all these dots. So we do what's called a best fit line. Okay, your graph tells a story, and from the reading the graph, give a relationship between the mass of salt added and the time taken. So from the graph, we can see that the more salt that you add, the longer it takes to dissolve. Okay, and then it asks us, guys, the more salt you add, the longer. Can you explain this relationship? Well, there's more salt to be dissolved, so therefore it is going to take longer. So guys, in the final question, it was to investigate whether Ariel or Persil washing powder is better at removing grass stains from white cloth, and you had to come up with an experiment using the headings to carry out this investigation. So you're all going to have individual plans, so I'm just going to write in So my plan for this would be to get our 2 t-shirts and rub them with the same amount of grass. Wash one t-shirt with Persil and the other with the Ariel, and then to compare your results. So for this experiment, we're going to need our 2 t-shirts, we're going to need grass, we're going to need our washing machine, our Persil or Ariel. You might need gloves for pushing the grass into the t-shirts, stuff like that. So guys, here's a very rough drawing of the apparatus that we'd use. And remember, we're not artists, we are scientists, so it doesn't matter the quality of your diagram. Just try your best and make sure you label everything so we know what it is. So in my diagram, you'll see it'll have the 2 t-shirts. We can see I have my Ariel, my Persil, and my washing machine. Now, it's also really important to remember, you don't have to use a white t-shirt in this. You could just use a piece of white cloth. So we could use a face cloth or any leftover piece of white cloth that's lying around. I just decided to use a t-shirt. So guys, a fair test means that the experiment is structured in such a way that we can compare things fairly. So, for example, we can't compare Usain Bolt to Mo Farah. Usain Bolt is a sprinter, Mo Farah is a long distance runner. Okay, so in order to compare them, they would have to run the same distance. And it's the same in this technique. So some things you could do to make sure it was a fair test is that you could make sure it's on the same washing cycle. And that means it's at the same temperature and it's run for the same amount of time. That you put the same amount of Persil or Ariel on the t-shirt. That you used the same amount of grass to create your stain. And that you let it dry in for the same amount. So that one isn't going in just freshly rubbed in and the other isn't going in where it's been sat there for ages. So here's a sample procedure. I would measure out my grass and I would rub it onto the white cloth or the white t-shirt or whatever you're using, and then I'd let it dry. I'd then wash the white cloth and I'd let it dry afterwards. Now it's really important we wash it at the same cycle and we dry it in the same way. So if we pop one into the tumble dryer, we must put the other into the tumble dryer. If we put one on the clothes horse, the other has to go on the clothes horse. If it goes onto the radiator, the other has to go onto the radiator. We compare, when it's dry, we compare the grass stain. Now, If we really want to be accurate and want to make sure it's a fair test, what we do is we take an average of results. So we would repeat it for the same cloth at least 3 times for each different for each sample and for each detergent. Now, with regard to your prediction, you might have a preference to one washing powder. I'm going to say that they're both equally as good. So both should wash the stain quite well. Now, just because I use Persil in my house, I'm going to make the statement that Persil will come out cleaner. Now, the only way to prove this is if I did the experiment myself. And we might have a bit more time in our hand over Easter, so who knows, maybe I'll end up doing that. Explanation: because Persil washes better. I have no real scientific explanation behind this, guys, only preference in this instance, and if I really wanted that answer, I would have to look into doing that experiment myself. I hope this has helped go through the worksheet. I know the graph is quite tough, so I hope you didn't spend too long stressing over it. Take your time going through this video, pause it, go back, see how you got on, and I hope you're all keeping well.